Next lesson is about compound probability. So we're going to talk about independent events today. You can find the probability of two different events happening. So our previous lesson was just on one thing actually happening. Independent events for today, to help you picture it, these are the two items. You can have a spinner and then to go ahead and roll a number cube. So when you talk about independent events, they are events that don't affect each other. So whatever happens with my first event, it's not going to affect what's going to happen with my second one. So a spinner and a number cube is an option. I could flip two coins. If I get heads on the first one, it doesn't mean that I'm going to have to get tails on the other one. I could flip a coin and then do a spinner. I could draw a letter. Let's say I put all the letters in a hat, and then I could flip a coin. There's a whole bunch of different examples here, all things that aren't going to affect each other. I could also pick a student out of our classroom and have them stand up, wave to everybody, sit back down, and then pick another student out. The same group of students is still there, even though that one student was already selected, they could still be selected again. So when we have two different events like this, we're going to be doing two different things. All we do is multiply the probability of the first event by the probability of the second event. So one of the ways that we can show this is done here in example 1. A letter tile is selected from this group and the spinner is spun. So we can use a tree diagram to show all the different possible options. So we could pick out G, we could pick out B, we could pick out E, or we could pick out A. If we picked G, we would then spin the spinner and we could still spin an A, a B, or C. If we picked B, we would spin the spinner and we could get A, B, or C. Same thing for E, and same thing for A. What this allows us to do is actually to realize that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. So it shows us and allows us to visually see how many possible outcomes could happen here. What is the probability that both will be a vowel? It's going to happen with the E and the A. It's also going to happen with the A and the A. So that's probability. We want a vowel on the first thing, and a vowel on the second choice. So our probability is actually going to be 2 out of 12, which is 1/6. I can also show this to you. There are 2 out of 4 vowels here, and 1 out of 3 vowels here, and that's going to multiply to give me 2/12, which is also 1/6. So using the multiplication method is the same as using the tree diagram method. The next page, the spinner and number cube are used in a game. What is the probability of a player not spinning blue and then rolling a 3 or a 4? So we want the probability of not blue. We typically just put a comma then to separate our two events. So there are 5 sections here. One of them is blue, so not getting a blue is 4 out of 5. And getting a 3 or 4 on a number cube would be 2 out of 6. And you can multiply them, and you're going to get 4 out of 15. A number cube is rolled and a coin is tossed. Probability of the cube landing on 5 or 6. So probability of 5 or 6, comma, and we want the coin on heads. So 5 or 6 would be 2 out of 6. And to get heads, that would be 1/2. That's going to give us 1/6 probability. Example 4, 4 oranges, 7 pears, and 5 apples. 4 plus 7 plus 5 is going to give us 16. Iggy selects a piece of fruit at random, returns it to the basket, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. So we want an apple, and then an apple. So there are 5 apples out of 16. He picks it, yay, puts it back. So there are still 5 apples out of 16. And we are going to get 25 out of 256 then. Example 5, P and Q are below are divided into congruent sections. The arrow will be spun once. The number in the section where the arrow stops on P will be added to the number in the section where the arrow stops on smear Q. What is the probability that the sum of the two numbers will be 5? It's not going to happen on any ones. It could happen with 2 and then a 3. So that could happen there. It could happen with a 3 and then a 2. And we kind of need to think to ourselves, all right, my first spin, it's a 1, a 2, or a 3. And then on each of these, it's a 1, a 2, or a 3, which means there's going to be 3, 6, 9 total options. So the chances of me getting that is going to be 2 out of 9 total options. Last example, Anita tossed 3 quarters at the same time. What's the probability that all 3 are going to land on heads? So we want heads, heads, heads. So the first quarter, it's a 1/2 chance. Second quarter, it's a half. And the third quarter, it's a half for a 1/8 chance.